Okay, so we're going to rewrite sine squared of x, cosine squared of x in terms of first powers of cosines of multiple angles. So like I just said, remember we can have multiple angles, means we can have 2x and 3x, 4x, 5x, whatever, but we want the first powers, so no squares, and it says of cosines. Well, what do we know? Well, first we're doing sine squared of x, cosine squared of x. Is there a way that I can take sine squared and get it to be a first power of cosine?
Yes.
How?
1 minus cosine 2u over u.
The power reducing formulas on the previous slide there shows that sine squared of u is equal to 1 minus cosine of 2u, so in this case I'm going to use x, over 2. Well, what about cosine squared of x?
Cosine squared of x.
It's 1 plus cosine of 2x over 2. Well, what can I do with that? I can multiply them, so straight across, so you're going to do FOIL on the top, and then just multiply 2 times 2 on the bottom. So I get 1 plus cosine of 2x minus cosine of 2x minus cosine squared of 2x. We'll deal with the square in a minute. Over 4. Simplify that. Your cosine of 2x minus cosine of 2x will cancel. So 1 minus cosine squared of 2x over 4. Well, you could, but the problem is I want first powers of cosines with multiple angles. So I need to get it to just cosine. I need no exponent, and I need multiple angles. But how about this? One thing we don't like up here is the fact it's a fraction, right? So maybe to help us out a little bit, I can common factor a 1/4 out of this. Or remember, dividing, let me try it like this. Dividing by 4 is the same as multiplying by 1/4, right? So instead of writing 1 minus cosine squared of 2x over 4, we can rewrite that as 1/4 times 1 minus cosine squared of 2x. That way we're not dealing with a fraction while we're dealing with the other stuff right now. Does that make sense?
Yes.
All right. But I still have a cosine squared, so I can do the same thing again. So I'm still going to keep my 1/4, my parenthesis, 1 minus, but how can I rewrite that cosine squared of 2x? 1 plus cosine of 2, you said u, but what is my u in this case? It's a 2x over, what was it, 2? Yes. Yes, ma'am. Because it was, because in the problem, or not in the problem, but in the formula, is cosine squared of u equals the rest of the formula. So my u is that 2x right there. So that's why in the formula, right here is where it has 2u, so the u is 2x. All right. So let's keep simplifying. So I've got 1/4 times 1 minus, see, 1 plus cosine of, somebody said it a minute ago, I think, 4x, right? What can I do? And what do you mean break it apart? Oh, you mean take like 1/2 and then plus cosine of 4x over 2? Yeah. You could. I'm thinking maybe let's go ahead and combine it though. Let's get that common denominator. So remember 1 is the same as 2 over 2, correct? So I still got my 1/4 times here. And so when I got my common denominator, I really get 2, and I'm going to distribute this minus sign. So minus 1 minus cosine of 4x all over 2. combine like terms. You can pull the 2 out of the bottom there, or you can distribute the 1/4 into it. It's up to you what you do. On either way, it's going to mean the same thing. I'm going to go ahead and pull that 2 out so I just have a number as a fraction. All right, I got my common denominator, and then when I combine those numerators, it was a minus 1 plus cosine of 4x. So I took that minus sign that's right there, and I distributed it into both of those. Is that what you're talking about? Hold on a second, let me pause. All right, so I'm going to go ahead and take that 2 off the bottom there. Remember, dividing by 2 is the same as multiplying by 1/2, right? So we get 1/8 times 1 minus cosine of 4x. And you can either distribute it back in, or you can leave it like that. Either way is fine.
That's the answer.
That would be our answer.
What you got, Zach?